Assalamualaikum and a very good morning to Dr. Azuddin and fellow viewers. We are from Group 1 and today we'll be presenting about bending moment in Experiment 5. For the first part, which is introduction, we can see that there's the distance between 2 points of the load and the weight of the loads which are shown in the diagram. So the diagram shows that a bending moment is the reaction that taken its place in a structural element when an external force or moment is applied to the element, causing the element to bend. For the objectives, number one is we to understand the basic concepts of bending moment, and number two is to measure the bending moment of material when subjected to different loads at different distances. Okay, moving on to the next part, which is scopes. Number one is to study the bending moment using the relationship between the same applied loads of 4, 8, 12 Newton to different distance of 110 and 250 millimeter for part 1. And then to study the bending moment using the relationship between the different loads of 4, 5, 6, 8, 10, 12, 16 and 18 Newton to same distance of 110 millimeter for part 2. And number 3 is to calculate the deflection in beam experimentally by multiplying it with spring constant of 150 millimeter and compare it with theoretical value by multiplying the loads and distance. Moving on to the next part, which is theory. So the bending moment is the algebraic sum of the applied load to the given distance from the reference point. The diagram below shows the bending moment relationship. So the first one is M is equal to F times L, which is theoretical, where M is equal to bending moment, F is equal to force, and L is equal to distance of force to moment. And the second one is M is equal to F times K, experimental, where M is equal to bending moment, F is equal to force, and K is equal to spring constant.
Experimental setup. The apparatus used in this experiment is the experimental beam of 900 millimeter was used and divided into two parts, which are part A and part B. Every scale line was 50 millimeter. The spring balance was attached to the beams with the lever arm on 150 millimeter, and there were three load hangers placed onto the beam. The hanger of P2 is fixed and also two bearings on stands to support the beam. There were also loads to alter to take the reading of the spring balance is recorded. Lastly, lever ruler is placed on the beam to make sure the surface is horizontal. Methodology Part 1. First, the distance from P1 to P2 is set 110 millimeter, and the distance from P2 to P3 is set 150 millimeter. Secondly, place the lever ruler on the beam besides the P2 between P2 and P3. Next, the beam is realigned by turning the adjustment of spring balance. While turning, observe the bubble in the lever ruler and make sure the bubble is at the center of the line. The initial value without load is recorded. Then, 4 Newton of loads is put on P1 and realigned until the bubble is at the center. The reading is recorded and the loads are removed. Then, step 5 is repeated on the hanger P2 and P3. 7. Step 5 and 6 is repeated with loads of 8 Newton and 12 Newton. Then, calculate the bending moment for experimental using the formula which the reading of spring balance times with the constant of 150 millimeter, which the loads is 4 Newton, 8 Newton and 12 Newton. Lastly, calculate the bending moment for theoretical using the formula the reading of spring balance which the load is 4 Newton, 8 Newton and 12 Newton times with the distance. Methodology Part 2. First, The distance from P1 to P2 and P2 to P3 is 110 mm. Secondly, place the level ruler on the beam besides the P2 between P2 and P3. Thirdly, the beam is realigned by turning the adjustment of the spring balance. While turning, observe the bubble in the level ruler and make sure the bubble is at the center. Then, the initial value without load is recorded. Then, put 4 Newton at P1, 8 Newton at P2 and 12 Newton at P3. Then, the beam is realigned and the reading is recorded. Next, remove the loads. 6. Steps 5 is repeated by using weight of load based on the table below. Then, calculate the bending moment for experimental using formula weight of loads times distance, which the constant is 150 mm. Lastly, calculate the bending moment for theoretical using formula weight of loads times distance, which the constant is 150 mm. Safety and precautions. First, the hanger need to be static. Reason, no change of distance to avoid inaccuracy reading for spring balance reading. Then, adjust the adjustment of the spring balance to realign the beam so that the surface of the beam is horizontal. The loads should be handled carefully because it is heavy. Solution: wear cover shoes to prevent injury.
Next, we move on into the result and calculation part. For part 1, difference, distance and same load. This is table 1. The table 1 contains the data that have we get and calculated for part 1, difference, distance and same load. For part 2, this is the table 2. It contains the data that have we get and calculated for part 2, difference, load and same distance. In this experiment, we have 6 calculations. So the first one is to calculate the net force. We use net force equal to balance reading minus zero error. Next, to calculate the bending moment. To calculate the bending moment, it is bending moment equal to net force times length of the spring balance. Next, to calculate the bending moment for the theoretical value, at part 2, we use theoretical value at part 2 equal to net force times distance that have we set at 110 mm. Next, to calculate the bending moment, theoretical, for part 1, we use theoretical value P1 equal to net force times distance P1 to P2. For theoretical value P2 equal to net force times distance P1 to P2 minus P2 to P3. Next, for the theoretical value P3, we use it is equal net force times distance of P2 to P3. This is a graph 1. Graph 1 is a load versus bending moment, actual and theoretical. Graph part 1 contains data for method of difference distance with same load. This is the graph part 2. Graph part 2 is a graph of the load versus bending moment, actual and theoretical. Graph part 2 contains data for method of difference load with same distance. In this data, we can tell that the theoretical value for bending moment are lower than the actual value.
So these are the discussion that can be made from this experiment. So from the observation that we can see from graph 1, we can observe that the higher the load, the higher the bending moment. We can conclude from there, when the experimental value increase, the theoretical will also increase. The small differences between the experimental value and the theoretical value could be caused by some potential errors such as zero errors and systematical errors. So from graph 2, we can observe that the higher the load, the higher the bending moment. Even when the distance is fixed, the bending moment will still increase. This is due to the formula of moment, which is force times distance, which distance and load will also affect the bending moment. So in conclusion, we can conclude that the experiment has shown on how distance and force will affect the bending moment of an object. From the data, we can see that when the load increases, the shear force and the bending moment will also increase. We can also see that the theoretical value and experimental value are a little bit different. Since the percentage error is less than 20%, we can conclude that this experiment is a success and the objective were achieved. These are the references that has been used to do this lab report. Thank you.